Welcome. Today let's solve day 9 Disk Fragmenter for Advent of Code 2024. For this first problem, what they're asking us is they give us something like, well, let's go over this here. They'll give us a string. And what this string means is that the odd indices represent a file ID. So for one here, that would be starting at 0. So 1 would be the size of the file ID, sorry, the size of the file as well. So you'd have 1, so notice here 0, this is the first file ID, and then 3, and then 5. So the value at that index represents the size. So at index 0, that's the file ID, and here's the next file. So that's 1. So yeah, that's 1. And then the next one is 2. So we skip an index. Now what do the values or indices between those represent? They represent free space. Here it is. Free space, like in memory, in terms of memory. So here's 2 empty spaces of memory. So this is 2. And here's a file with file ID 1, and this file is 3 block sizes, whatever they account for. And then we have 4 free memory or free spaces of memory, and then we have 5 of that file ID, which is 2. So remember, this first file ID is 0, second file ID is 1, then in chronological order. So when we're given this 1, 2, 3, 4, 5, it represents this structure. So what they're asking us to do is, they don't like the free spacer. What they'd like to do is move any file from the back to the front to what's the word, to occupy the free space. So here's that same representation here. So what they do is they say, okay, this 2, let's move it up to the front. There's a space available. This 2, there's another one. So now these 2 free spaces are now occupied. And then, sorry, they continue on from the back all the way to the front until the original representation gets, in their terms, defragmented and looks something like this. So this is, they want to optimize in their minds, they want to optimize space use. So from the back, they try to move any file to an empty space. And this is just a longer version of that. So this is represented by this thing here, this string. So notice here there's 2 zeros, so here's 2 zeros. Then it says followed by 3 empty spaces, 3 empty spaces. Now the next file ID after 0 is 1. So here's 3, so they have three blocks of file ID 1, and so on and so forth. As the last piece of information I'd like to clarify is that moving forward all the way through moving forward all the way through, notice we have 4 here, which means we have 4 8s. But the 0 means we have no free space. So notice how the 8s are immediately followed by 2 9s. So I wanted to make that point clear. And something that probably should have been stated, but I think it's fair to assume, is that there are no files with no spaces. So every file must occupy at least 1 block. Okay, and they just specify move move file blocks one at a time. So move the 9 here, so this goes here. Move the second 9 here, 8 here, and then now we'll be focusing on this free space and move this 8, and so on and so forth. So eventually originally we're given this string, and we need to convert it to this. But now we're not done. So now we need to perform what they call a file system check. So considering this new consolidated memory, they want us to multiply the index times the value and sum that. So for here, notice how at this first index of 0, the value is 0, so we get 0 times 0. At this next index, the value is still 0, but the index is 1, but we get 0 again. Now we're at 9, which is at index 2, so here we're here, and we get 18. Now we're at 9, but index 3, so we get 27. And this continues on and on until we're done with the string, and we're left with a value of 1928. And that's for this example here. Okay, so I think that's enough to get started. So let's do that. Where are we? So here's the data. So what I didn't realize was it's one long string. So, well, now that I do, I mean, initially I thought it was going to be a list of strings or list of something, but it's just one long line. So I read the line in, I stripped the new line character, and then I converted. I probably didn't need to do this, but I converted every element to a string, and now I have a list that holds each of these. So let's just look at this one here. So 1, 2, 3, 4, 5. So we'll actually run that one. Test 901 -1. So we would have something like this, or L should have equals 1. Yeah, 1, 2, 3, 4, 5. We can run that, I guess. Python. Let's save that. Problem9.py. Let's save this. Oh, and then let's print it. Sorry. Okay. So my idea is to use a left and right pointer. Maybe I've been doing too many leet code problems, so I kind of think like that. But in any case, let's go over how we'll approach it. So I'm actually going to use this one better because I think it's longer, so we get a better. I'm not sure, but I think that's okay. We'll try it. So my idea is this. So we have we'll have some string here, which is whatever. So my idea is this. We'll use the left pointer. So the left pointer will start at 0, and the right pointer will start at the end. So we'll just call n-1, whatever the length of the string is. So what we'll do is the left pointer will always, I'm gonna write it down. So the left pointer will always wait at spaces. And then the right pointer will wait for left to have spaces, and then perform movement. So let me just go over that. What I mean by this. So here's left, and then here's right. So I start left at 0, and I start right at the last index. So notice though, the left pointer will always wait at spaces. So this first index is not a space. So that means, so left pointer, sorry, and I want to go over something too. The whole goal of my approach was this. I don't want to have to create this and do this. I didn't want to create this. I wanted to calculate it all along just by this, directly from this to the answer. And so the question is this, like how are you going to do that? So well, it's not too bad. So remember, like this, let's just look at this here. Let me copy this. So remember, there aren't any spaces in front of this guy. So right now, so look at this first file. There are no spaces in front of it. So that means we automatically know the ending value that this will contribute. We know what it will contribute. So what I mean by that is, for this one, there's 2 zeros. I know that the file ID is 0. I know that. Here I know the file ID is 0. And I know there's 2 of them. So I can just perform 0 times 0, which is the first index. And since there's 2 of them, so I know that occupies another index, which is the index 1. But that's the same file ID, which is 0. So I know that. I know that. So then that's one thing that helped me. So it'll help us. So I said, so when I'm advancing, when advancing to a space location, calculate the file contribution before moving to space location. Okay, so in this case, well, that's easy. So I know it's 2, so I know there's going to be at this location the file ID is 0. So file ID is 0 here. So sorry, what I do is probably in my mind, well, this file, we know the file ID, but we'll also keep track of the index, the overall index. So I'll put this up at the top because this is important. So this index represents, so they give us this here. So this is, the left pointer will always point to this string and the right pointer to the string. But we'll need an index because remember the index stores this thing, and this is the final representation that contributes to our final total. So even though this string is, I think this is a string of 19, I think this is a length of like 30 or whatever. So we need to keep this in mind as we progress through. So that's what I've done here. This guy will hold that. So index will be 0. So when I'm calculating the contribution of 2 here, well, I know that'll be easy. That's going to be what? So index times file ID. And then index, then I increment it, then it'll be index plus 1 times file ID. And that should make sense. And then I advance left here, advance it. So now left has spaces, and it's saying, okay, right, I have spaces for you, move them over. So then it says, okay, no problem. Okay, so then we do that. So right says I have 2 files, okay, so 2 files, okay, and it moves them over. So we need to calculate the way I calculate the file ID is I say the index divided by 2. So well, it's always important to know if the last index is a space or if the last index is a file. So I just use integer division to figure that out. And then we use a little bit of it. I'll show that later when I do the implementation, how to figure that out. But in this case, we know that since it's odd, we know that the last location is a file. So that means, let me see, so the file ID would be, I guess, just whatever the index, let me see, we'll just say, I don't know, we'll just put position divided by 2. So this whole thing is 19, which would put R at 18, and then 18 divided by 2 is 9. So we know the file ID, and we know, so this guy has, the left pointer is waiting with 3 spaces. This right pointer is holding 2 files. So we know we can move 2 over. So let's move 2 over. So we say, okay, no problem. So we multiply now index plus 1, because remember index started at 0. Now it's at 1. Now it's another 1. We'll just say 2 times the file ID. And index plus 3 times the file ID. But yeah, imagine though I'm incrementing the index. And then so on and so then, but remember though, the left pointer will always wait at spaces. So there's still, remember, we only used 2 of the spaces. So there's 2 left because the left pointer is waiting at 3 spaces. This R pointer was waiting at 2 files. So R says, okay, no problem. I'll skip 2 because it doesn't want to go to the spaces. It wants to go to the file. So it'll say, okay, so we'll adjust R minus equals 2. And then it'll be at another file location. Then it says, okay, 4. So it'll move 1 over. It'll move 1 over. So it'll do this here. I think it's this. And this would be 4. But remember now the file ID would change because the right index changed. So the file ID, this becomes now, well, just put -1 here for now. But just imagine that we're keeping track of the file ID. So here the file ID was 9. Again, then we use the way we calculate the file IDs. It's that index hard divided by 2, integer division by 2. So this was at 18. Now this is index 16. 16 divided by 2 is 8. So this would be that. And now notice, so we're still here. We're going to stay here. But notice that we're stuck because left doesn't have any more spaces. So if it doesn't have any more spaces, it needs to move forward. But remember, it can't. Remember, right could. Sorry. So remember, right's here. So right could always skip 2 because it doesn't care. We don't care about spaces at the end. We could leave them there. So that's why right can always, like, so for example, if right was here at this 8, we can skip to this 7 location because we don't care about spaces. But with the left pointer, we can't just jump to spaces. Remember, we need to calculate. Where's that at? Did I write that somewhere? Yeah. So when advancing to a space location, calculate the file contribution for moving to that space location. So we need to first calculate this contribution for these files here. So how do we do that? The same way we did for this guy here. So the index is now at index plus 5. So I know I'm doing this, L plus 1. Then I say index plus 5 times the file ID. And the file ID would be remember, it's the indexed hard divided by 2. So 0, 1, 2, 2 divided by 2 is 1. So yes, that makes sense. This is 1. And then, yeah, and then carry on. And then same thing over here. Now we're at index plus 6 now, times the file ID. So we need to do this how many times? Well, we need to do this 3 times because that's how many, that's the value, that's the size of the file. And then we'll just do this again. And that's basically it. So the point is, we move left one, we always move left 1 space at a time. So on the first one, we calculate the contribution of those files. And then next we wait at spaces. And then right says, I have files for you, and it moves as many as it can until there aren't. It moves as many as it can until there's no more files. But remember, the left has to always have spaces available. If it doesn't, it always makes spaces available. So at some point though, they become, here. And what do we do when they're close to each other? Well, it could be, suppose you have this here. Suppose this is an edge case that I think should be pointed out. Suppose though left was at spaces and right was at 5 files. So we could move 5 of the files to the left spaces, but we'd be left with 2. So at that point, let's see what we have here. Let's see how I can do this here. So at this point, so remember, this was at 5, and we move 3 of the files over. So now there's 0 spaces here, but there's 2 files remaining. So remember, we still need to advance L. And so at this point, L and R would be at the same location, but we need to perform we still need to figure out the contribution of those files. But now just remember, there are only 2 of those files there, because we moved 5 of them over to what were spaces. And now there's 2 files left. And so when we implement this, we'll use like the left and right pointer. We'll ensure that we'll do something like this, or while, where is this at? Something like while left is less than or equal to right. I wanted to make that point clear. Okay, cool. Let's implement it. So let me just comment this out for a bit. Let's do that. Let's do that. Okay, let's get started. Where are we at? So yeah, so let's initialize everything. So left equals 0. We'll need to set n equals the length of L. And well, where is right going to be? So depending on so n minus 1 if n is odd, else it's at n minus 2. Okay. What else? Oh, we'll need to set a total to hold the total. What else? And I think those are all the initializations that are required: left, right, length, and the total. Okay, so let's get started. So remember, L will always skip the first one, but it needs to calculate. It needs to calculate file contribution. So let's do that. So let's erase this junk. So how does it do that? So it says, okay, let me see. So we don't really need this, range of L of left. So L of left is the value. So in this case, let's move this down. So in this case here, yeah. So in this case, it would be 2. And then so 2 times we need to contribute those files to our total. Oh, one thing I forgot was the index. That's a big one, the index. Okay, cool. So let's do that. So we say, okay, total plus equals the left divided by 2. So this is the file ID times the index. And then we need to increment our index. Cool. Very good. Moving on. So now we were here. Put that L here. Put a comment there. And now, so now we've contributed, or we've taken into account the contribution of those files. So now we need to move, what the hell? We need to move left forward 1. So let's do that. So we do here, left plus equals 1. And then over here we need to, let's get rid of that. And right now right is, where is that at? Right is here at the last index. One thing though we need to keep in mind is that if left is beyond right, yeah, it's fine. I think we can do this, right? I don't know if we need a break. Let's just do that. Left is greater than right, we can break. And we'd be done. Yeah, once left is beyond right, we can break. That's good. Okay. I can probably put an equals there, but I think that's fine. It's more, I think it's more appropriate if you leave it as left is greater than. In any case, remember, so now we're here. So left is waiting for right to move files there too. So let's do that. So what we want to do is we want to say, okay, we want to stay here as long as there's spaces there. So we'll say, okay, while L of left is greater than 0, left is gonna wait there as long as left is holding spaces for right. It's gonna wait there. So what we're gonna do is we're gonna say while left of right has files and L of left has spaces. Okay, great. The difference is that when right runs out of files, it tries to get more files. So let's do that. So in any case, considering they both have, there's files at right and there's files at left. So what we do is, well, we reduce them. So L of right, remember right now this, at every index, this has a 3 there. So we're gonna decrement it until there's nothing there. So eventually for our, what we're holding, remember we're holding an array, so we're going to decrement this so there's 0 there. It doesn't matter because, I mean, we only care about the total. We don't care about anything else, so we can decrement it with no problem. So we're going to decrement right, so that's going to be minus equals 1. L of left, we're going to decrement it, minus equals 1. And then, so now we know, so once we move this 9 here, we can calculate the contribution. So let's do that though. So then the contribution will be total plus equals the file ID. The file ID was right divided by 2 times the index. And every time you adjust the total, that means you're moving the index too. So don't forget that. So then we do index plus equals 1. Okay, great. Now, if we have exited this loop, that means that either one of two things: either there are no more files to move, or there's no more spaces. If there are no more files to move over, so if there's no more files, then we move to the right by 2 indices. Hope that makes sense. Remember, so we're here at right. So eventually, if we move 2 files, so that means there's 0 files here. And now we've moved, we take away 2 because we moved 2 files there. But now R goes here now, 4, and L is still waiting there because it says, I still have 1 space for you. You can move one of your files over here. So it moves R spaces to the right. If right is less than left, then we can break. So suppose we were, so suppose we were something like this, I don't know. We were something like this, and if right runs out of files, we don't, and so in theory, we would move R over here. But yeah, we don't need to do that because we know we're done. It would make sense. So that's why I have this this check here. And otherwise, and then we'll go back around, and then if left still has files, if left still has spaces, it'll run this loop again. Okay, so then this will happen on and on and on until left runs out of spaces. If we break out of this loop, that means left has no more spaces, which means left needs to move forward once. Okay? So it moves forwards once, and then it goes back out to the start of this loop. So let's put it back where it was. So in this first one, we were let's try to go over this again. Let's see. So here so initially we started here, and we moved 2 files over. Then we subtracted then we moved R. Al said, I still have one space for you. Okay, so the R move said, okay, I'm gonna give you one more file, so I'm gonna give you 3 here. And then now this is at 0. Sorry, this is at 3, and this is at 0. Okay, that means that we would have broken out of this loop here, and then right is not 0, so it doesn't move, and right is not less than left, so it doesn't move. So neither of these happen, but we do break out of the loop, and we move forward 1, which means L goes here. And these are files, and these files will not move. So we need to calculate how they contribute to our that file checksum. So that's done here. We did this earlier. So we say this is 3 here, so that's the range of 3. We do this 3 times. The file ID times the index, and then you increment the index. And that's it for the problem. That's it. So we can just print out the total. Where is that at? So print out total goes here. Hopefully this works. Print total. I think we can run it. So what are we at? We're at this is test 9. So this was so test 9 would be, I think it'd be 1928. It should be this here, 1928. So let's do that test, or let's run it. 60. Where did I mess up at? Okay, let's look at this. Did I less than or equal to right? Oh, yeah, I apologize. We're using the wrong file. So this should be 2. Run it again. Okay, great. 1928, and there you have it. How long has this been? Yeah, I think I'll stop here. Yeah, I'll stop here and do the second part on another video. But if you found this in any way helpful or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care. I'll see you in video 2.